Hello. Welcome to yet another devlog. It's part 11 on DNS Server in Z. Yeah, I'm continuing the challenge from CodeCrafters, and I am kind of stuck in the section where I need to parse the compressed question label. In the last stream, I got an answer. Yeah, I was making in my version. I was making some wrong assumptions, and then I involved AI, and I got a suggestion. But this version is also not compiling. I tried to debug it here and there, but I think that's me brute forcing to come up with a solution and not necessarily learn it. I think I'm going to slow it a little bit down now. Try to re-implement this logic. Basically, yeah, based on what I remember. So I'm going to pick this out, put it inside my scratch buffer. To just have a backup. I believe I'm going to go back and forth here to sanity check some stuff. There was also one interesting point which I then noticed in the previous stream, and that was this method to own the slice. So the idea here is exactly the problem I had in my parse method, where I was passing the allocator, but I was allocating memory inside the method, and I was deallocating it while passing out the ArrayList. Right, and by the time the client was trying to read the result of my function, this memory was already deallocated. So my solution back then was to make it the responsibility of the client to deallocate the output at the end of their process. It might be, I think, an optimized solution in some scenarios where memory management is very crucial and memory space is very limited. But the AI solution here is also interesting because it's initializing the ArrayList. It's also deallocating the memory when the function is finished running, but the return value is a U8 array, right? And how it's doing it, a U8 slice, let's call it. How it's doing it is using this method. I haven't tried it, so in this stream I'm going to go over it. I spent some time to see what's going on. The idea is simpler than I thought. So in my version, I was trying to recursively call my parseLabel method when there was a compress method, but I can have the procedural path as well, because when we jump out to read the compress pointer, there is no point for us to get back to where we are. So I don't need to track anything. All I need to do is to jump to the pointer that I need to read it to the end, and where I see the null-byte, I've read my label, right? The only catch is that I lose my cursor where I was reading it. So for the next domain, I will have a problem, and the method here is addressing that by tracking a value called final offset, which it updates it in two places. First, if it's a jump is happening, it's basically setting the final offset like this, and if there wasn't a jump, it's going to set it to the current offset. This is it. I also have some doubts why it's called these. It's calling this the first jump. I have no idea why it's happening. So I thought this is a better idea for me to try to rewrite this myself while I'm explaining it to myself. So yeah, that's the plan for today. I'm going to also again block like 1 hour today to work on it. Hopefully I can finish it this time. But yeah, that's the scenario, and I'm going to get rid of my own method. So yeah, let's start. I'm going to start with defining the function parseLabel, and then I have the buffer as usual, and then the offset to read. Nothing is different here. The only thing which was annoying to me as well was to keep the naming, and I'm going to use I wanted to have a consistent naming which makes sense, and I wasn't successful in my tryout first, but I'm going to continue using naming convention that AI suggested here as well. So offset of type usize, and then allocator of type std mem allocator, and the return value would be we're going to attach to an array list, which means we might have an error. So I'm going to use it like this, and then a struct, and then I will have the name, and for the name I just described, we're going to have a u8, and then offset would be usize. Actually, let's do it like this, and then down here what I am going to have is let's see, first of all, of course, parent offset, which was offset, and then I'm going to use jump for it for now, and set it to no, it doesn't make sense, right? So let's call it no jump. That's that. And one more thing that we need is final offset, which is going to be used at the end, which is this struct, actually like this, name equal to empty, and offset would be equal to final offset. Yes. Right. So far so good. Then I am going to have my big loop where I'm going to check for buffer offset to not be equal to 0, and buff offset is less than buff of length. Yeah. So what I need to do here now, I'm going to have post label size, and that would be buff offset. So the first thing that I learned there was this comparison for extracting the most significant bit, first two significant bits of the first 2 bytes, actually first byte that I'm reading, right? That most significant bits, I need to extract it like label size and with 0x30. This is basically masking out all the values after the first 2 bits from the left, zeroing them out and keeping these 2 first, and what I need to do is basically I need to check the code. I need to check the example. What I was doing is exactly directly checking if the remaining is this. Okay, and only this way we knew that we exactly have the flags for the pointer set, right? And then I'm going to call this one pointer, which basically I need to extract from the rest of the bits. And for this, it was doing like label size 0x3f, right? And then reading all 8 bytes, which I'm not sure about the direction used here, but let's assume that's the thing. But what I didn't get here still is, oh yes, so we need to have the first 2 bytes used as the address. So what I have extracted so far is, let's assume we have it like 0000000. This is the first 2 bytes of the string that I'm reading. This piece here is going to be responsible for the flag that it's a pointer, this first bit, and then this one carries the address. This is how I was doing it in my function, but then I learned it's only these 2 bits that are relevant to being the pointer flag, and everything after that is actually able to communicate the address, and that's why this needs to also be merged with label, actually buff label size, actually no, offset +1, like this, right? And then I can remove this part, and down here I could continue, right? And by continuing, it would jump here and then doesn't see this and going to process the rest of the tags as expected. but I need to do some housekeeping, and if actually maybe it's more readable to consider it jumped and set these to false. So I'm doing it in the opposite way compared to what AI suggested. So if not jumped, right, I am going to set jump to true. What else do I need to do? And for final offset, I'm going to skip those 2 bytes that I described down here, and that would be current offset plus 2, right? And what is the error here? It has been never mutated. That's fine, but let's see, what am I missing? There is an extra condition here. If the current offset plus 1 is bigger or equal than the buffer len break. I'm not sure where this situation is going to happen. So it's useful to have this piece, right? Because we are basically how do you say taking in a user input and external systems input that we don't trust to, but in theory, if the message is correct, it shouldn't happen. But my code by no means is safe. I'm sure of it. I didn't take care of a lot of stuff when I was developing, and that's probably something I'm going to invest more time in my next project. But for this one, I didn't take care of it that much. But a good rule of thumb here to make sure of that piece, not here, if current offset plus 1 bigger than or equal to len. I think so far so good, right? I think we have everything in place exactly like it was suggested up here. And okay. Okay, I made a mistake here. Here I needed to compare it with the current offset or the offset right on the bottom. So the next piece is to read it, right? And previously what I was doing was in a loop. I was constantly checking the label and jumping. So if we have the offset, so if this didn't happen or happen, it doesn't matter now anymore, right? I have the label lengths, the name, let's do class. Let's call it label. The label is buffer from current offset plus 1, because the current offset was indicating the size, and then plus, oh no, current offset plus 1 up until Okay, maybe it's easier to do const label start is current offset +1, and then here do label start up until label start plus label size. Am I missing anything here? I think not. So then what else do I need to do? I need to update the current offset to be equal to label start plus label size +1. Then if not jumped, but if the jump didn't happen, the final offset I'm going to update for now and set it to current offset. Am I missing anything? No, I assume not, right? And the next part is to have my allocator used. So I'm going to call it name and type it as std ArrayList of type u8 and set it equal to empty, and then the for name dnit my allocator, right? And then down here try name append slice, and then here passing the allocator allocator, and what else do I need to pass in here is my label. Right, and the magic was happening here where I had my name to toOwnedSlice, and documentation, the caller owns the return memory, empties this array list, its capacity is clear, making the init safe but unnecessary to call. Beautiful. And then again here I need to pass in the allocator. This is weird. What else? I think I missed something, and that's the fact that when I'm continuing, the current offset should be equal to pointer. Is that it? Or did I make a mistake? Current offset is equal to pointer. So I'm going to simplify this and set this to current offset, remove this line, and then there was a recursion here. And then yeah, this dot separator I wasn't using in the names or when I was extracting the previous version, but I'm going to implement it here. What else? Label start, label end. I think I have a similar logic, and then append the slice. You have the label. Current offset is label end. We didn't label end, was it label? Yeah, I think this would cause an issue. I'm not 100% sure, but when it's a label end, it means the next byte that we've seen is 0. But here, what I'm trying to check and consider it as the label length is the offset that start. Okay, no, we don't have a 0. Okay, I think this is correct. Let me quickly check this. Ziglings. I want to see if the last value is it inclusive or exclusive. So if we do 1, 2, 1, 2, 3. For item, for element in pointer, do lm, and then we have 1, 2, 4. First is okay, this is this part. Array slice from 1 to end, and end is 4, and 1 is this, right? And 4 is this, and I assume that's exclusive. And then if that's exclusive, this logic is correct. So one thing I need to do is to change this. However, on the final offset, what happens is, yeah, that remains untouched. What else did I miss? Result append the slice. Yeah, that part I understand. And then here, escape the null terminator if we haven't jumped. So if the line is compressed, sorry, the label is compressed, we won't end up having a null terminator there. That's why here, only if the jump has not happened, it's considering that. So if not jumped, and final offset plus 1 is still less than buffer len, final offset plus equal 1. I think that works, right? If not jumped, I have this logic twice, so here I already set it to the current offset, so I can safely increase it over here. Now two things I need to get back to. One is this piece where the current offset plus 1 plus label length is still less than equal to the value. Yeah, so how can I write it more readable? I have a label start. If label start plus label size is bigger than problem, right? So I'm securing this one, and then this dot logic, it says if result items dot len bigger than 0, append dot character to it. So here is trying to only add dot. Okay, I think it would be safe if we don't check it. Oh no, it's doing it before appending the actual value. But maybe what I can do is everything. Oh, no. Then at the end I don't want it. Okay, now I get it. Why why it's doing it. So I'm doing the same. If name dot items dot len bigger than 0, here add dot try name dot append, here allocator, and here a dot. So I think now I potentially will end up with the same type conversion error here, which we need to debug. I think this is now kind of straightforward to me. I understand it piece by piece. I didn't comment it that much, but I think it makes sense in my mind right now. Let's try to compile. Yeah, exactly. So the problem is type u3 cannot represent integer value. Eight. And where is this type u3 coming from? Does anybody else experience this? All on-site egg value expected time. No, I think it's not the same, but it's okay. Shift is happening. Yeah, expected time future found u8 solved. So here we had for entropy 0 to 7, we had byte, and then int cast byte to U8. Eight left shifts on 8-bit integer. I'm guessing this is happening because shifting is manipulating the value directly without ultimately casting. And since in n-bit unsigned integer can only be left shifted exactly n-1 times, without intervention from arbitrary precision like in Python, we get this weird error. I'm just unclear about why it's U3 shouldn't be the same as H. Am I missing something? Zig version 12. Yeah, I'm the same in the same ship as this guy. It's random. Let's see if there is anything else. If not, I'm going to ask I can perform bitwise operation with an unsigned 8-bit value on RHS. Okay, I tested several cases and found that RHS of shift must be log to n of the LHS of the shift. For example, RHS I assume is right hand side, left hand side they are referring to. So must be right hand side of shift must be log to n of left hand side. For example, if you want to make a bitwise operation with left hand side of the shift, type U64, the RHS of the shift must be U6 or lower. Okay, these are the cases. Thanks a ton for explanation, but as I already mentioned, I did read docs and I know the fact that how Zig enforces this rule on, it looks like this is a known to be anagronomic, and there is an open issue about it over here. Format friendly definition of shift operators. Currently, if you shift with a count-time non-RHS, everything is easy peasy lemon boy squeezy. However, if RHS is runtime known, it requires an often awkward cast. There are two chases to resolve this. I'm kind of blind, I don't see what is the cast. So if I have this X, U32, the same as here, and Y is U32. If I do this, it's fine. If I do this, this is not fine, but I'm doing this, I believe. Right? Expected this to be runtime known. Let's ask Claude for help. Brittle. Can you explain the following error and how I can Okay, there occurs because you're trying to store the value 8. I think the error is actually in how I'm shifting it. It is considered as U8. I don't think that's going to help. Oh, wait a minute. Current offset is a U size. Cast the result as U16. Use a more appropriate mask. I'm trying to get the address part of a compressed DNS label from the first 2 bytes, and current offsets type is usize. You're parsing DNS compressed label. For DNS compression, you need to extract the 14 bit offset from the pointer format, the first 2, yeah, and then correct. This issue is known, the issue is that label size is declared as U3, but you're masking it with, here's the fix. Or more explicitly, so if I cast it with the result, what am I casting here is okay, that resolved the issue. So issue wise, label size is declared as U3. Why is that? The label size is U8 actually, that's not correct. But when I was doing this, it was casting it into U3. Okay, this is weird. And now the error is, yeah, that kind of makes sense. I can try it. Doesn't support field access. parseLabel. Where am I? 76. Because here I also need to try. Okay, now better. CC. Panic. Index out of bound. Good. This is kind of getting annoying. I'm still on in the same place that was before. So the first piece is red, and now the question is on line 78. Cool. So if I here print, I want to have what I want to have. Buff line offset. Okay, one thing that I need to remove is this, right? Because I'm taking a bit up there. Beautiful. That solved the problem. And however, kind of domain value I'm getting is weird. Print. Do this, and then print parse label dot name as a string. Okay. Let's put in here. Maybe I can figure out what's wrong with it. First thing first, I think this is vice versa. It should be def first, and then dot this. What's wrong? I had a ChatGPT session here. So it was abc longestdomainname.com and def longestdomainname.com, right? abc Okay, let's see what exorcism sorry, CodeCrafters will raise as an error here. Somehow I completely messed up the processing order, but how? So let's do this. Let's run it with the echo that I had, the short version, which was single domain. What I don't get is this piece. While over here it is reading CodeCrafters, but not the .io part. And then if I echo the longer version that I had, this is really funny. How is this happening? What I can do let's forget this piece. What I can do is to print label here. I think what's happening is that I'm not skipping the null-byte. Properly. Maybe I need to move this piece. But this shouldn't be, right? The null byte only happens after all the labels got processed. I'm going to try this. We got worse now. It completely skipped I. Yeah, so this is not the problem. Okay, let's try it with CC and try to divide from there. Right, with CC. First, it sees ABC. Wait a minute. It's always trying to read it 3 by 3. Const label length is buffer. Yeah. Way better now. Way better now. I'm happy. What else? Let's see, where is my print statement? I'm going to pick this. And now print it over here with the value being parseLabel.name. I take a sip of water. Yeah, there is a comment from ByteBiter saying I sometimes stop by to watch you code. Nice work, man. I wish there comes a day when I can be as good as a programmer. As I assume he means me being good. Thanks for joining the stream. I don't feel like that, to be honest, about myself. This kind of task that I'm doing right now, I assume to be quite trivial for seasoned programmer with system level programming knowledge. So I'm trying to teach myself that. So we are in the same state, I believe. You just need to start. And thanks anyway for the good comment. So what I wanted to try is this. Yeah, the labels are parsed correctly now. It looks better, but it's scrambled over here. How am I using this in the main? Here I have received bytes. I have my questions. Right here, what did I have? Yes. I have my questions. This is the question section, right? It should hopefully get what? Cannot, yeah. The names are correct there. Wait a minute, but here I'm having compressed pointers. Where is that coming from? Oh, this is the answers. Questions. Ah, okay, I remembered. For questions, okay, this is the piece I need to fix. So the problem is that I'm basically passing the raw question as the value here. So what I need to have a 2-bytes method for my questions as well. And that's like this over here. Okay, so sub fn 2 bytes. I'm thinking somehow probably I can just make it question object property, like this being self, which is a question, and what I return is bytes. And then I was using an allocator, I think, right? In 2 bytes, not there, but somewhere in the answer, I think. Yeah. Oh, actually, the same method is used for that. Yeah, it will be pretty much the same. Let me just copy this. I want to just finish it. Have a working step here today. Do this, remove this part, and this would be question. Allocator here would be self data len plus 12. No, the size would be bit different. So len of this plus 4. I'm going to try that. Right. And then offset 2 bytes. No, basically I'm going to first write the oh yeah, here I was hard coding the compressed version, but I'm thinking maybe CodeCrafters accepting it somehow. No, it's not. It says BAD RDATA now. It doesn't even care about my question. RDATA is part of the answer. There was a note somewhere. Actually, I think it's better to not invest much time on this. There was a comment. If you are seeing overflowing header size, is that the thing? No. If you're seeing this error after a while, then it is likely that your server is not responding with an appropriate ID, but that's not the case. The ID is patching for the first response. In the same request. The thing is, here unlike the previous tryout that I had, I don't have a reference as this implementation. Okay, the first thing is, no, not like that. I want this version to see how they respond this at plot layer. Okay. Wait a minute. Hold on implementing this first. And for raw, keep it to okay, there is a bug here. The offset is not correct because the offset should be first var offset equal to parseLabel dot offset. It worked there, it should work here. Or even safer to play with. Remove this. Have the offset here, but set the offset after that to parseLabel.offset. I think this is the correct version. Otherwise, it was always setting that to 0, which we are doing it in a loop, and that doesn't make sense. Index out of bound, index 100, then 41. So I'm way beyond my time limit today, and I think I have a new challenge now. I made it work. There was a bug in how I was counting offsets in the parser itself, but now I need to reflect this fix somehow to prevent it from happening. But that I'm going to take on in another session tomorrow. Thanks for watching and spending time here. Again, ByteByter, thanks for your heartwarming comment. Wish you all a very nice evening. See you next time.